Hi. Hello again. Well, let me share with you this time. Inside our industrial connectors, a more core professional vocabulary, or a professional technician. The technical difficulties are called motor clearance and creepage distance. Here we mentioned earlier, industrial connectors related. A very central word is called RAMs. It's reliability, availability, maintainability, and security. When our connector customers choose the type, especially industrial high currents, the first priority is safety and reliability. The customer is choosing a product. The first concern is, my stuff is applied in this system. Is it safe? Is it for people? This damage is irreversible to the entire system. That is related to electricity. Safety related. We all know about voltage and current. In the process of voltage, this particular field, we have a daily application. Everyone should know better. For example, we use summa in our house. Electrical appliances with higher current? For example, high-power ones like this. Refrigerator. This, motor? The moment we start, or we plug this in. When the plug is plugged into the plug-in board. Do you all have a feeling? Occasionally discharge arcs. Then this arc. It will cause. We are using this appliance. Some hidden security risks? What about this lost arc? It's actually caused by our high voltage. According to some of the principles of physics we have learned, that arc, it's a type produced by high voltage. Ions in an electric field. After the ion excitation, it's a kind of lost channel. What we see through our eyes. It's called an arc. But in fact, it is a lost channel formed. This lost channel has several characteristics. The first temperature is very high. It's very hot. Can reach thousands of degrees. Lost temperatures can reach thousands of degrees. Secondly, the voltage is very high. Or rather, it's TV. When it comes to voltage, everyone must be more clear. But actually in the process, it's a television electric field of electron-ion electrons. This thing. And the electrical gap we're going to talk about today. It's tied to creepage distance. Electrical gap. In this specialty of our connectors, in this system, it has a technical word called clearance. What about the creepage distance? It also has a. The technical word is creepage. What is an electrical gap? Simply put, it is between two conductors. In the air, under these conditions of air, it can lose the minimum distance of connection. This is the base of our connector. There are two conductors on it. Our most common type of connector. Two conductors between two conductors. Because after the conductor is powered on, it will have a TV in between. Between the two conductors. And of course, this medium is air. A smallest. Minimum safe distance. That's the electrical gap we're talking about. As for further back, this is more professional. If anyone behind us is interested, can we talk in private? So let's just talk about this, some basic ones. This is an introduction to the term. That's what we call the electrical gap. Suppose I am between these two conductors. One added some so-called insulation measures, or so-called protective measures. Let's say I put a piece of plastic in the middle. They use it as insulation. Then at this time, these two conductors, it can't pass between. It's transmitted directly through the air. It doesn't have this condition. How about that? It goes down the surface of your insulation. We'll find a root. The smallest root out. The sum of this root. We call this the creepage distance. This is very visual. Creepage. This is very visual. What about these two? Is our user, or when the customer chooses this product, must be considered. Many times our users will know. Say my product. How much voltage is there in my entire motor system? How much voltage? How much current? However, under this voltage condition, what connector should be used? In fact, from the customer's perspective, many times it may not be clear. You know, like I have 500 volts. 50 such a working environment. The customer will choose some connectors. Then this connector is what we usually talk about. It's pitch. It's spacing. How much should it be? Clients of our app. Is the probability that it is particularly clear in this regard? You may choose the wrong one at this time, because this is related to your whole connector. The operating environment in an electrical system are closely related. And as a connector designer or our solution provider, in knowing the client expresses my work environment after current and voltage, we will combine actual scenarios, provide customers with corresponding safe and secure products. Then you have to consider your electrical clearance and your creepage distance. How do you calculate it? First of all, we have it. International standards. For example, IEC's 60,644. There is obviously a prize inside. This is the standard of the International Electrotechnical Association. Make it clear that our creepage distance, our this motor. What conditions should the clearance be under? What kind to choose? Distance from that. With these conditions. In addition to these conditions. What else should we have with creepage distance? Related to electrical clearance. First of all, we just talked about the electrical gap. It is because of the electricity market voltage difference. One like this is produced. Lost power on distance channel. That is related to this voltage field. We'll talk about that later. Because you are air. There's carbon dioxide, nitrogen dioxide in the air. Some air like nitric oxide. The electric arc generated between these two TVs. It's basically electron breakdown or ionization. Some molecules in our air. An electrical channel is generated. Then if my air pressure decreases, that means I have fewer molecules in the air. The higher the air pressure, the more molecules there are in the same air. So under low pressure conditions, our electrons are actually getting smaller and smaller, less and less. We have less and less molecular weight. That's getting less and less molecular weight. Explain that it is involved in the entire process of ionizing molecules. The less resistance it encounters, well, that would create a problem. We are in a state of low pressure. It may not be suitable for the same product. You, for example, my product, I can handle it. I have a product. I am under normal air pressure conditions. I can handle 1500 volts. Withstand voltage. Can withstand 1500 volts. But if you go to a low pressure environment, like Shizong Plateau, so let's say it's 2 kilometers above sea level. At an altitude of 2 kilometers. Sorry about that. 1,500 volts withstand voltage. Possibly at 1,000 volts. my product may be broken down. So when our system is applied to both under normal conditions, this ring, border, it's also used at some high altitudes. In some low-pressure environments, then our selection must be upgraded. Under normal circumstances, if I go for 1,500 volts, then if at the same time this product should also be suitable for low voltage, low pressure, high altitude, then my product must be improved too. This one adapted to the same air pressure. This kind of adaptation? Okay, another thing. This electrical gap, it is not only related to air pressure. It will also interact with our temperature and humidity. It's also relevant. In fact, this is easy to understand. Our university studied university physics in. There will be some in the electronics and electricians you learn. Our this current voltage. Our electrical system under different humidity conditions. Different this. Under this moisture-containing condition, its resistance and voltage are different. Is the performance different? So we are choosing this according to the actual usage of the customer to choose this product. Or when choosing some of its technical parameters, you have to synchronize and take into account the environment in which it is used. Is that what we're talking about? Motor clearance. There will be. Some of our colleagues will ask us. Then the environment given by our customers is often, or the size in the given system, it's fixed. Or is it? When there are not many ways to change, what to do then? So in the electrical gap, under the two conditions of electrical clearance and creepage distance, of these two core conditions, then we need to do something. Necessary precautions. That's a lot of times. In the middle of the connector, we see, is there no such thing as an insulator? This insulating wall? It's two separate conductors at this time, if it is because of our motor clearance. So we have to do one in the middle. It's called insulation. After this insulating 3 grid is done, we started to calculate its creepage distance because at this time, the motor clearance is invalid, the passage between them, because of the production of this insulator, resulting in, it can't directly form the so-called the concept of electrical clearance, and that gives rise to the concept of creepage distance. Then, under these conditions, we need to increase the creepage distance. That is to say, increase this safety factor. Then I need to put this wall, this distance, or this shape. The longer the circumference of this feature, the better. That's what we do in product design. And when selecting, a very core point that must be considered about this creepage distance and electrical gap. So that's it. Thank you very much.